All right, so let's take a look at number 56. 56 said, write the decimal as a fraction or a mixed number. So 56 was 2.707, and the 0.707 is repeating. All right, so I'm going to take that 2 and I'm going to set it aside. So I'm going to set x equal to 0.707 repeating. All right, this goes out to the thousandths place. So once I set this up, I have to multiply both sides by 1,000. So I'm going to rewrite that x where we have 2 repeating parts. Well, I just know I'm 2 repeating parts. 707 no, it would be 7 again, wouldn't it? Yep. So this would be 707, and this is what's repeating, right? Okay. So now I'm going to multiply everything by 1,000. So when I do that, I move my decimal 3 places. So I end up with 1,000x is equal to 707.707 repeating. Question so far? All right. So now I want to subtract that 0.70 repeating, or 707 repeating, off. God bless you. Because that's the problem. I don't want that repeating part on there at all. Well, 1x equaled 0.707 repeating. So that means that I have to subtract a 1x off the other side. It will always be a 1x. You're always going to either multiply by 10, 100,000, 10,000 perhaps, probably not that big, but then you're always subtracting a 1x off. So you're always going to get some form of 9x, 99x, 999x. That will always be the same, is equal to one of my repeating parts. And now I'm going to divide everything by 999. All right. So I don't believe that they have a common denominator. So this x is equal to 707 over 999. That's not my final answer because the original was 2.707. So my answer is going to be 2 and 707 over 999. Are you cool with that? Ada. Say that one time. 54. Yep. Brendan, are you cool with that? Awesome. So let's take a look at 54. 54 said I have negative 1.36, and the 36 is repeating. All right. So the same process. I'm going to set x equal to just the 0.36 repeating. Well, that 6 is in my hundredths place. So, Danny, you're correcting your work if you need to, if you haven't already. The 6 is in the hundredths place, which means I have to multiply both sides by 100 when I get to that point. So I'm going to set that up. So x is equal to 0.3636 repeating. So I have one entire extra repeating part. So now I'm going to multiply both sides by 100. So I get 100x equals, well, you guys, remember, the goal of this, and this is what you need to keep in mind is the goal. Because if you don't reach this goal, you've done something wrong. So if you, by mistake, are like, well, I multiplied in the first example, Matthew, put the calculator down. I multiplied in my last one by 10. The example we did in our homework was multiplying by 10. I think I need to multiply by 10 here. If I multiply both sides by 10, all right, what I end up getting, if I multiply both sides by 10, I end up with 10x equals, well, I only move my decimal one place. I get 3.636 repeating. Have I gotten an entire repeating part in front of the decimal? No, I haven't. So I have not accomplished my goal. So I don't want you to necessarily just memorize this because you have to memorize it. Understand why we're doing what we're doing. We want to get an entire repeating part in front of the decimal, so then I can subtract off the repeating part after the decimal, which is what our problem is to begin with. All right, so now that I've accomplished getting a repeating part in front of the decimal, I'm going to subtract off that 0.36 repeating, which means I subtract a 1x from the other side. So I have 99x is equal to 36. Now divide both sides by 99. X equals, well, 36 is divisible by 9, and so is 99. So 36 is 4, 99 is 11. So this is 9 elevenths. Well, the original had a negative 1 on it, so this is negative 1 and 9 elevenths. What did I do wrong? Because you're all holding your hand up that I did something wrong. Amanda. Do you know what I did wrong? Sarah, do you know what I did wrong? Oh, I said 4 and I put 9, didn't I? I meant 4. Thank you. 4. Thank you very much for correcting me. 4. Yes. Because 6 divided by 3 is not 3. 6 divided by 3 is 12. Right? Yep. All right, what else do you guys have for me? Okay, put this away, get your notes out. All right, now we're going to dive into fractions. All right, and adding fractions, adding and subtracting fractions. I'm hoping this first section on it is easy. I'm hoping this first section on this is easy, just so we warm up to it. So today is the 10th. We are chapter 5, section 2. And we're going to be adding and subtracting fractions. Colin, you're going to work up on your desk, right? Why don't you get everything else off your desk you don't need? You know what I mean? There you go. Okay. For us to add and subtract fractions, what do we have to have? For us to add and subtract fractions, what do we have to have? Matthew? They do. We must have a common denominator. Now, lucky for you, in this first section, in 5.2, they're all going to have the same denominator. 5.3, we are going to switch to unlike denominators, okay? Okay. So these will be relatively easy. All right, when we get to subtraction, we'll have some that kind of throw us off a little bit that I want you guys to understand. All right, so let's start with some easier ones. All right. So one night, 77 100ths of the moon's 77 100ths of the moon's visible surface is illuminated. That means we can see it. So one night, 77 100ths of the moon's visible surface is illuminated. All right? The next night, an additional 9/100ths of it is illuminated. What fraction of the moon's surface is illuminated on the second night? Alright, we do need to come up with a game plan for this. Alright, so we have our parts equal to our whole. What's my whole here? What information is my whole here? Sophia? Say that one time. When? Fraction of moon illuminated on second night. Equals. What are my parts? Colin? Okay. So I'm going to say additional illumination. Okay, like I said, this first bit of homework for this should be relatively easy. So my first night, I have 77/100ths plus my second night is 9/100ths is equal to x. When I'm adding fractions, what am I actually adding? And this is something that I would not take for granted, because once we get into multiplication, someone's going to forget this. When I'm adding fractions, what is the only thing I'm adding? Brendan? Yep, so just add our numerators. Brendan, what is 77 plus 9? So I have 86/100. Can I simplify that? All right, what common factor do 86 and 100 have? Yeah, I'm going to start off with 2 as well. So 8 divided by 2 is 4. 6 divided by 2 is 3. 100 divided by 2 is 50. So far I have 43/50ths. I think that's simplified, isn't it? All right, so I'm going to say on the second night, 43/50ths of the moon's surface is illuminated. Don't forget, you guys need to write in a sentence stating your answer. Not so bad, huh? All right, let's talk about subtracting them. And then we're going to look at mixed numbers. Questions so far? Okay. These regular fractions are the super easy ones. It's the mixed numbers that are going to throw us off a little bit, because I make you keep it in mixed number form. You may not change your mixed numbers to improper fractions for me. All right. So I want you to simplify. Negative 4/7 minus 2/7. All right, so I'm going to go back to, I want you guys thinking about how you're adding your integers. Adding and subtracting integers. Those rules still remain of how I want you guys to do it. So I want you to do adding the opposite first. Just like if these were integers. So I have negative 4/7. What does that mean on ours? That I say I want you adding the opposite. What does that actually mean? Cameron? Yep. If a fraction's negative, just put the negative sign on the numerator. Okay? So now we go ahead and just do our adding rules. So I have -6 sevenths. Not so bad, huh? All right. Now I want you to simplify this one, and then we're going to start talking about mixed numbers. 1/10 minus -3/10. All of you finish that. Now, go ahead. Again, if you have a negative fraction, just put the negative on the numerator. Because in your book, it's going to show this. It's going to show a negative out in front. That's the same thing as a -3/10. All right, what am I going to do here? Alex? Excellent. So go ahead and finish that for me. Which simplifies to? 2/5. How many of you guys are cool with this? All right. So now let's talk about adding and subtracting mixed numbers. The book and I do not agree. So you're going to do what I'm telling you, not the book. Although what the book is saying is true. The book is turning mixed numbers into improper fractions. All right, I'm not going to let you do that. I want you guys using mixed numbers. They're harder, but I need you guys to understand how to do them. All right, so must leave mixed numbers as mixed numbers. Do not change into improper fractions. That's a big one for me, because I want you understanding the complexity of adding mixed numbers and subtracting, or more subtracting mixed numbers. That's really where it comes in. All right, so let's just do an example of adding. So let's say I have 5 5/9 plus 2 7/9. All right, what I want you guys doing is I want you to line them up vertically, just as if you were adding 2 and 3 and 4 digit numbers. So I want you to line up math vertically. And now I'm just going to add my fractions first. What's 5 plus 7? Or 5/9 plus 7/9? Sophia? So I have 12/9. What is 5 plus 3, Sophia? 8. Now this 12/9, what do I need to do with it? Because I can't leave it like that. Addison? What do I have to do with 12/9? No. I mean, we can do that, but that's not what I'm getting at. I can simplify it, but that doesn't solve my problem. So what do I have to do with 12/9? AJ? Oh, this should be a 3. Thank you. Thank you, Addison. That's what you were trying to say to me? Thank you. What do I have to do with my 12/9? Yeah, I need to change my 12/9 into a mixed number. All right, so I take my 12/9, so 12 divided by 9. That's going to divide into that once. I have 3 left over, so this ends up being 7 plus 1 3/9. So I'm going to have 8 1/3. How many of you guys are okay with that? Okay. So let's talk about subtraction. needs to see what's up there. You good? Okay. All right, so let's do, so I want you to simplify. 6 2/3, a negative 6 2/3, plus 3 1/3. I'm adding two numbers with different signs. So what am I actually doing with those numbers? If I'm adding two numbers with different signs, what am I actually doing with those numbers? Coral? Subtracting. So I have 6 2/3 minus 3 1/3. All right. You always subtract the bigger minus the smaller. All right, so I'm going to start with my fraction. What is 2/3 minus 1/3? Sophia? 1/3. What's 6 minus 3, Sophia? 3. So my final answer is going to be 3 1/3. Is it positive or negative? Sophia? Negative. That's the easy one. All right, this is the harder one, and I need you guys paying attention to this. So let's say I have 4 1/5 minus 2 3/5. All right, I'm just going to stack this. I have 4 1/5 minus 2 3/5. I always subtract the top one minus the bottom one. What do you notice? I always start with my fraction first. What do you notice about this? Addie? So what do you think I need to do here to be able to do this subtraction? You need to borrow. That is correct. This is now what we need to do is we need to borrow a 1 from the 4. How many of you guys saw that you needed to do that? Awesome. So this is what I want to see. You're going to take that 4, you're going to make it a 3. You're going to add to your 1/5. Well, what is my 1 going to look like if I'm adding it to 1/5? Addie? What does my 1 look like? I don't disagree, that's what I'm going to get. What is my 1 going to look like if I have to add it to 1/5? Molly? 5/5. I have to see that that's what you're adding to your 1/5. I don't just want you changing that 1 to a 6. I want you guys to show that this 1 that I've borrowed is now plus 5/5. So when I do that, I end up with 3 6/5 minus 2 3/5. Now I'm going to do my work here. So 6/5 minus 3/5, what do I get? Cullen? 3/5. What's 3 minus 2? 1. There's my answer. Let me tell you the mistakes that I see people make. People get to this part right here, and they end up doing 3/5 minus 1/5, and then they do 4 minus 2. Can you guys see the mistake they made? They take the bigger fraction, they subtract off the smaller, even though you can't. You have to take that bigger number, which is the 4/5, minus the smaller number, which is the 2 3/5. So you have to do 1/5 minus 3/5. You can't go in the other order. Does that make sense to you guys? Yes? Okay, let me give you another one. Alex, you had a question? Are you sure? Okay. So I want you to do this problem. Negative 3 3/7 plus 6 2/7. All of you do this, please. Remember, always set it up vertically. Use the one above it as your guide. And you guys, because we're adding two numbers with different signs, when we subtract them, you always subtract the bigger minus the smaller. I'm not leaving it in the order of 3 and 3/7 minus 6 and 2/7. That's not how we do it. If I have negative 5 plus 10, aren't you doing 10 minus 5? You're always doing your bigger minus your smaller, okay? So someone tell me, what am I going to do here? Whose voice have I not heard? Amanda, what am I going to do here? Excellent. So what do I have when I do that? So 5 and 9/7 minus 3 and 3/7. Excellent. Keep going. Excellent. And there's my answer. Questions on this process? You guys good with this? Okay. So now let's throw some variables in there. All right. So let's say I want you to simplify. This is when you go back to remembering what is it that we have to add together when we're adding or subtracting fractions. So if I have 3a over 20 plus 5 over 20. What am I actually adding here? What am I actually adding here? Ada? Yeah, I'm actually adding the numerators. Can I add 3a and 5? No, so I'm just going to leave it as what that says. This is simply going to be 3a plus 5 over 20. If that had 5a, if this said 3a over 20 plus 5a over 20, I could add them then, right? And I would get 8a over 20, right? All right, so let's take a look in case I have that. So if I have 3a over 20 plus 5a over 20, this ends up with 8a over 20. Can I divide out common factors between the 8 and the 20? Yeah, so go ahead and do that. They both have a common factor of 4. That becomes a 2, that becomes a 5. So this ends up being 2/5 times a, or 2a over 5. As long as our denominators are the same, we just add or subtract our numerators. You guys cool with that? Even if they have variables in them. You guys good? Okay. We are good to go. My odds, go ahead and go to your lockers, please. We have one more week of odds going to your lockers.